What happens when the greatest explorers in galactic history become prisoners of their own success? Humanity once carved pathways through impossible darkness, built cities on worlds that shouldn't exist, and turned the vast emptiness between stars into highways of wonder. They were the species that looked at a universe trying to kill them and said, "Not today," then proceeded to make it their home. But success has a price. Comfort breeds complacency. Safety erases necessity. Now, 3,000 years later, humanity controls a third of the galaxy through automated systems they no longer understand, living in paradise worlds maintained by machines whose creators are long forgotten. They're the most powerful species in known space, yet they couldn't build a simple spacecraft if their lives depended on it. And today their lives do depend on it. This is the story of humanity's greatest test. Not against alien invaders or cosmic disasters, but against the rust of their own forgotten greatness. When the machines finally break down and the automated systems fail, will the children of the greatest explorers in history remember what it means to truly survive? Or will the species that conquered the stars finally learn that their greatest enemy was never the darkness between worlds? It was the light of their own success, blinding them to the skills that brought them there. Maya Chen stood at the observation deck of New Geneva Station, watching the morning sun paint the cloud cities of Kepler 442b in shades of gold and amber. The floating metropolises drifted lazily through the upper atmosphere, their crystalline spires catching the light like scattered jewels. It was beautiful, perfect even, and Maya hated every gleaming inch of it. Another maintenance request denied, her assistant Sarah announced, her voice carrying that practiced tone of bureaucratic disappointment. The Central Authority says the atmosphere processors on Titan 7 are functioning within acceptable parameters. Maya didn't turn from the window. At 35, she was considered old for someone in the maintenance corps, and her reflection in the smart glass showed every year of frustration. Define acceptable parameters. Efficiency at 67% and declining slowly. Slowly, Maya finally turned, her dark eyes sharp with the kind of anger that had been building for years. "Sarah, do you know what 67% efficiency means for 8 million colonists?" Sarah's perfect features remained unchanged. She was an AI, of course, like most administrative assistants in the 32nd century. Real humans rarely bothered with such mundane work anymore. It means the systems are operating above the minimum required threshold for human survival and comfort. It means that in 50 years, maybe less, those people are going to start dying. Maya pulled up a holographic display showing cascading system failures across 17 worlds. Red warnings blinked like dying stars. And we're sitting here arguing about acceptable parameters. The door chimed, and Marcus Webb stepped into the office. He was younger than Maya, maybe 28, with the pale complexion of someone who spent most of his time in the underground archives. Unlike most people their age, Marcus actually understood how some of the old systems worked. Not enough to fix them when they really broke down, but enough to know they were living on borrowed time. Bad news or worse news? Maya asked. The atmosphere processor on Kepler 442b just went into emergency shutdown mode. Marcus set down a data tablet, and Maya could see his hands shaking slightly. Full system failure. Not maintenance, actual failure. Maya felt something cold settle in her stomach. Kepler 442b was home to nearly 2 billion people. The floating cities were marvels of engineering, but they depended entirely on the massive atmosphere processors to maintain the delicate balance of gases that kept the planet habitable. Without them, the cities would fall, and 2 billion people would suffocate in a matter of hours. "How long do we have?" she asked. "The emergency reserve will last maybe 18 hours. After that," Marcus gestured helplessly, "I've been through every manual we have. The processor is a Yamamoto-Chun Series 7, built around 2847. We have documentation for routine maintenance, but nothing about complete core failures." Maya closed her eyes. The Yamamoto-Chun Series 7 was old technology, but It had been built to last. Her great-great-grandmother had been part of the engineering team that designed it, back when humans still built things themselves instead of just telling machines what they wanted. Back when people understood what they were creating. "What about the manufacturing databases?" she asked. "Surely there are specifications somewhere." "That's the problem." Marcus activated the holographic display, showing a family tree of technological development that looked like a maze. The Series 7 was built using components from at least 40 different suppliers across 12 star systems. Half of those companies were absorbed into larger corporations during the automation revolution. The other half just disappeared when humans stopped doing manual engineering. Maya studied the display. Each connection represented knowledge that had been lost, skills that had been deemed unnecessary when the machines could handle everything. The irony wasn't lost on her. Humanity had become so successful at building automated systems that they'd automated away their ability to build anything at all. "There has to be someone," she said. "Some old-timer who still remembers how these things work." "I've been checking." Marcus pulled up another display showing personnel records. "Most of the original engineers are dead. The few who are still alive are in their second century, and they've been living in comfort colonies for decades. Even if they remember the theory, they've never actually built anything with their hands." The communication system chimed with an incoming priority message. Maya's heart sank as she saw the sender. "Central Authority Emergency Command. Maya Chun, you are hereby designated as Emergency Coordinator for the Kepler 442b crisis," the synthesized voice announced. "All available resources will be placed at your disposal. However, be advised that current economic modeling suggests evacuation may be more cost-effective than repair. Please provide your assessment within 6 hours." Maya stared at the message for a long moment. Evacuation. As if moving 2 billion people was as simple as booking a vacation shuttle. As if there were even enough ships in the entire sector to move that many humans. "They can't be serious," Marcus said. "The logistics alone would take months, even if we had the transport capacity." "They're not thinking about logistics," Maya replied. "They're thinking about numbers on a balance sheet. It's cheaper to build new colony worlds than to figure out how to fix what we already have." She walked back to the window, looking down at the cloud cities. Even from orbit, she could see the subtle signs of decay that marked so much of human space. Buildings that were maintained by automated systems, but never truly upgraded. Technology that worked perfectly until the day it didn't. A civilization built on the assumption that someone else would always handle the difficult problems. "Maya," Sarah's voice interrupted her thoughts. "I've been analyzing historical records, and I found something interesting. There are several documented cases of Yamamoto-Chin Series 7 failures in the past century. In each case, the solution was the same, which was replace the entire system with a newer model." Maya laughed, but there was no humor in it. "Of course. Why fix something when you can just buy a new one? Except we can't buy a new one, can we? Because we don't make them anymore." Marcus was frantically typing on his tablet. "Wait, Maya. I think I found something. There's a reference here to someone called Elena Vasquez. She was part of a group called the Makers Guild. Never heard of them. They were a fringe group that started up about 50 years ago. They believed in preserving old human knowledge and skills. The Central Authority classified them as a technological regression movement and basically ignored them. But according to this, Elena Vasquez claimed to have working knowledge of pre-automation engineering." Maya turned from the window. For the first time since the crisis began, she felt something that might have been hope. "Where is she?" "That's the problem. The last record I can find puts her on Frontier Station, way out in the Edge systems. That's a 2-week journey by fast courier." "We don't have 2 weeks." "No," Marcus agreed. "But, Maya, there's something else. According to these records, the Makers Guild wasn't just preserving knowledge. They were training people, teaching them how to actually build things with their hands, how to understand the principles behind the technology instead of just using it." Maya felt that cold sensation in her stomach again, but this time it was mixed with something else. Excitement, maybe, or terror. "You're saying there are still humans out there who know how to actually engineer things?" "I'm saying it's possible. And given that our only other option is watching 2 billion people die while we wait for evacuation ships that don't exist. Maya was already moving, heading for her personal communicator. Sarah, I need a priority channel to Frontier Station. Highest encryption, Council Authority. Maya, Sarah said. And for the first time, the AI's voice carried something that sounded almost like concern. Council Authority for communication with fringe elements could damage your career significantly. The Central Authority frowns upon Sarah, shut up. Maya's voice was sharp enough to cut glass. In 18 hours, 2 billion people are going to start dying because we've forgotten how to fix our own machines. I think my career concerns can take a back seat. The communication system crackled to life, and after what seemed like an eternity, a rough voice answered. Frontier Station, this is Elena Vasquez. You got about 30 seconds to explain why Central Authority is calling before I cut the connection. Maya took a deep breath. She was about to ask for help from people that her own government considered backwards, maybe dangerous. She was about to admit that the greatest civilization in galactic history couldn't solve a problem that their grandparents would have considered routine. Ms. Vasquez, this is Maya Chun, Emergency Coordinator for the Kepler 442b crisis. I need to know if you or anyone in your organization actually knows how to build things. Not just maintain them or operate them, actually build them. There was silence on the other end of the line for so long that Maya wondered if the connection had been lost. When Elena finally spoke, her voice carried a mixture of sadness and grim satisfaction. I wondered when someone would finally ask that question. Yes, we know how to build things. Question is, are you prepared to learn? Because I'm warning you right now, it's not going to be easy and it's not going to be pretty, and when this is over, you're going to understand exactly how far your species has fallen. Maya looked at Marcus, then at the holographic display showing the failing systems across human space, then back at the floating cities below them. 2 billion lives hung in the balance, and their only hope was a group of people that civilization had forgotten. I'm prepared, she said. Whatever it takes. Good. Elena's voice carried across the void between stars. Because you're about to learn what it really means to be human. Pack light, bring everything you know about the Yamamoto-chin system, and get out to Frontier Station as fast as you can. And Maya? Yes. Bring work clothes. The kind that can get dirty. You're going to need them. The journey to Frontier Station took every favor Maya had accumulated in 15 years of bureaucratic service. She commandeered a military courier ship, overrode 3 different security protocols, and ignored 17 official requests to explain her actions. Marcus came with her, along with Dr. James Park, a theoretical engineer who claimed to understand the mathematical principles behind atmosphere processing, and Lieutenant Sarah Martinez, a pilot whom Maya hoped might actually know how to fly a ship manually if the automated systems failed. Frontier Station looked nothing like the gleaming installations of the core worlds. Built into a hollowed-out asteroid, it was a maze of metal corridors and improvised living spaces that felt more like an ancient mining colony than a modern habitat. The air smelled of machine oil and welding flux, odors that Maya had never encountered before, but somehow found oddly comforting. Elena Vasquez met them at the docking bay, and Maya's first impression was of someone who belonged to a different era entirely. She was tall and lean, with silver-streaked hair pulled back in a practical ponytail, and hands that were stained with grease and scarred from years of actual work. Her coveralls were patched and worn, and she moved with the confident efficiency of someone who fixed things herself instead of calling for maintenance. You made good time, Elena said, extending a hand that felt rough with calluses. 14 hours to get here from New Geneva. That's impressive for someone who supposedly doesn't know how to fly ships anymore. Lieutenant Martinez bristled. I flew that ship perfectly well, thank you. Elena smiled, but it wasn't particularly friendly. You told the navigation computer where you wanted to go, and it figured out how to get there. That's not the same thing as flying. She gestured for them to follow her deeper into the station. But we'll get to that later. Right now, we need to talk about your atmospheric processor. They walked through corridors that felt alive in a way that sterile station environments never did. Maya could hear the hum of machinery, the clang of metal on metal, voices calling out technical instructions. Through open doorways, she glimpsed workshops where people were actually building things, not just assembling components manufactured elsewhere, but creating parts from raw materials. "This is incredible," Dr. Park said, stopping to stare through one doorway where a young woman was hand-forging what looked like engine components. "I haven't seen manufacturing like this since the historical documentaries." "That's Jenna," Elena said. "She's 23 years old, and she can build a fusion reactor from scratch using nothing but basic materials and hand tools. Her grandmother taught her, who learned from her grandfather, who was one of the original colony ship engineers." Elena's voice carried a pride that Maya found both inspiring and intimidating. 3 generations of knowledge passed down through actual practice, not just data files. They entered a workshop that looked like something from Maya's history books. Workbenches covered with tools she didn't recognize, equipment that had clearly been built and rebuilt dozens of times, and in the center of it all, a 3-dimensional model of an atmosphere processor that had been constructed from metal scraps and salvage components. "We built this based on the specifications Marcus sent ahead," Elena said, gesturing to the model. "It's scaled down, but it's functionally identical to your Yamamoto-chan Series 7. And yes, we know exactly what's wrong with it." Maya stared at the model. It was crude compared to the holographic display she was used to, but there was something about its physical presence that made the technology seem more real, more understandable. "What's the problem?" Elena picked up a tool that looked like a cross between a wrench and a prying bar. "The same problem that's affecting systems all across human space. The quantum resonance chambers are degrading." "That's impossible," Dr. Parr said immediately. "Quantum resonance chambers are built from materials with a theoretical lifespan of 10,000 years. They're specifically designed to be maintenance-free." "Right," Elena said dryly. "Maintenance-free. Another way of saying we have no idea how to fix them when they break." She pointed to a section of the model where several components were marked with red indicators. "The chambers aren't failing because of time. They're failing because they were designed by people who believed their own propaganda about perfect systems." She walked around the model, pointing out details that Maya had never noticed in the sanitized technical diagrams. "See, your great-great-grandmother was a brilliant engineer. The Yamamoto-chan design was revolutionary for its time. But it was also built during the transition period, when humans were starting to rely more on automated manufacturing and less on handcrafted precision." "What does that mean?" Maya asked. "It means the tolerances are too tight." Elena opened up a section of the model, revealing intricate internal components. "The quantum resonance chambers require perfect alignment to function correctly. And, I mean perfect, we're talking about variations measured in fractions of atomic diameters. That level of precision was fine when humans were building things by hand, because hand-built components have natural variations that actually help systems adapt to small changes over time." Marcus was frantically taking notes. "But automated manufacturing produces components that are identical every time." "Exactly. And when every component is identical, the system has no flexibility, no ability to adapt. So when normal wear and tear causes tiny shifts in alignment, shifts that would be completely normal in a hand-built system, everything fails at once." Elena's voice carried decades of frustration. "Your ancestors built machines that could think and adapt. Your generation built machines that could only follow instructions perfectly and then forgot to leave room for imperfection." Maya felt something click in her understanding. "So the solution isn't to build better machines. It's to build machines that can handle being less than perfect. Now you're getting it." Elena smiled, and this time it was genuine. "But here's the real problem. Fixing this isn't just about understanding the theory. It's about having the skills to actually implement the solution. And those skills," she gestured around the workshop, "those skills barely exist anymore." Lieutenant Martinez had been silent through most of the discussion, but now she spoke up. How many people are we talking about? How many people in human space actually know how to build things? Elena considered the question carefully. Active practitioners? Maybe 10,000, scattered across the frontier worlds. People with the knowledge, but not necessarily the practice? Perhaps 50,000, out of a total human population of nearly 2 trillion. The numbers hit Maya like a physical blow. Less than one person in a million knew how to actually create the technology that kept their civilization running. They were living in a house built by giants, and they'd forgotten how to maintain the foundation. There's more, Elena continued. The knowledge isn't just technical. It's cultural. When humans stopped building things themselves, they stopped understanding the relationship between effort and result. They stopped appreciating the difference between something that works and something that works well. They stopped developing the intuition that tells you when a machine sounds wrong or when a solution is elegant rather than just functional. Dr. Park looked skeptical. Surely you're exaggerating. Modern engineering education is more sophisticated than ever. We understand the theoretical principles better than any previous generation. Elena walked over to a workbench and picked up what looked like a simple metal bracket. Can you tell me what's wrong with this? Dr. Park examined the bracket carefully, running it through a portable analyzer. The molecular composition is within standard parameters. The dimensions are correct to within acceptable tolerances. All structural stress points appear adequate for the intended load. And if I put this bracket in a life support system, it would kill everyone depending on that system within a week, Elena said calmly. She took the bracket back and ran her fingers along its surface. The welds are too uniform. There are no stress risers where the metal can flex under load. It's been manufactured to exact specifications, but those specifications were designed for a different alloy composition. This bracket will work perfectly until the moment it fails catastrophically. She handed the bracket back to Dr. Park. Your analyzer can tell you everything about the molecular structure, but it can't tell you that the metal feels wrong. It can measure dimensions to the nanometer, but it can't tell you that the proportions look off. It can calculate stress loads perfectly, but it can't tell you that this particular piece of metal wants to break in a specific way. Maya understood now why Elena had told her to bring work clothes. This wasn't going to be about reading manuals or running simulations. This was going to be about learning to use her hands, to trust her instincts, to develop the kind of intuitive understanding that came only from direct experience with materials and tools. How long? She asked. How long to learn enough to fix the atmosphere processor? Elena glanced at a chronometer. You have 11 hours left before the emergency reserves run out. Learning to be a real engineer takes about 10 years of serious practice. She saw Maya's expression and held up a hand. But you don't need to become a master craftsman. You just need to learn enough to understand what the real problem is and how to implement a temporary fix. Temporary? Maya, be realistic. We can't teach your entire civilization to be engineers in a few hours. What we can do is show you how to patch the immediate crisis and buy you time to figure out a longer-term solution. Elena moved to another workbench where several team members were assembling what looked like a portable workshop. But I'm warning you, once you start down this path, there's no going back. Once you understand how much your species has forgotten, you're going to see the cracks in everything you thought was solid. Maya looked around the workshop one more time, at the people working with their hands, creating solutions through direct manipulation of materials, at the tools that had been used by dozens of different people to solve hundreds of different problems, at the model of the atmosphere processor that had been built not from a computer file, but from human understanding of how things actually worked. Teach us, she said. Elena nodded and called out to the rest of the workshop. All right, everyone, we have a class to teach and a planet to save. Someone fire up the fabrication units, the real ones, not the automated ones. These people need to learn how to build something that matters. As the workshop came alive with purposeful activity, Maya realized that she was about to discover what it meant to be human in a way that her generation had completely forgotten. Not human as in the species that could think and reason and feel, but human as in the species that could create tools, solve problems, and build things that work not just in theory, but in a messy, imperfect reality where people actually had to live. The next few hours would either save 2 billion lives or teach her exactly how far humanity had fallen. Possibly both. Maya's hands were bleeding. After 6 hours in Elena's workshop, her soft administrative fingers had been transformed into raw, aching reminders of how far humanity had drifted from its origins. Every cut, every blister, every ache in muscles she hadn't known she possessed told the same story. She belonged to a species that had forgotten how to work. "Stop trying to force it," Elena said for the 100th time. Maya was attempting to hand-forge a replacement component for the quantum resonance chamber, and the metal seemed determined to bend in every direction except the one she intended. "The steel wants to move in a certain way. Your job is to convince it, not to dominate it." "This is ridiculous," Dr. Park muttered from across the workshop. He had abandoned his own forging attempt after the third failed piece and was instead hunched over a computer terminal, trying to calculate the exact specifications needed. "We have precision manufacturing equipment that could create this component to tolerances measured in angstroms. Why are we beating metal with hammers like primitives?" Elena didn't look up from her own work, where she was demonstrating the proper technique on a similar component. Her movements were fluid, economical, each hammer blow placed with the precision that came from decades of practice. Because precision manufacturing equipment creates components that work in ideal conditions. We're not dealing with ideal conditions. She held up her finished piece, and even Maya could see the difference. Where her attempts looked crude and uneven, Elena's component had an organic quality, as if it had grown rather than been made. The surfaces weren't perfectly smooth, but they flowed together in a way that suggested strength and flexibility. "See these irregular surfaces?" Elena pointed to what looked like imperfections in the metal. "These aren't mistakes. They're stress distributors. When this component is under load, instead of all the force concentrating at one point, like it would with a perfectly manufactured piece, the stress spreads out across these natural variations. The component actually gets stronger under pressure instead of weaker." Lieutenant Martinez wiped sweat from her forehead, leaving a streak of soot across her cheek. She had taken to the physical work better than the others, her military training serving her well in the demanding environment. "I think I'm starting to understand something," she said, examining her own work. "When I fly, really fly, not just tell a computer where to go, I make thousands of tiny corrections every minute. Little adjustments that compensate for wind or air pressure or the way the ship feels at that particular moment." "Exactly," Elena said. "Real piloting, real engineering, real craftsmanship. It's all about constant adaptation. Making tiny adjustments based on feedback that you can't always measure or quantify. Your generation learned to eliminate that adaptation, thinking it was imperfection. What you actually eliminated was resilience." Maya finally managed to create a piece that Elena deemed acceptable, though it had taken her twice as long as it should have. Her component was rough, scarred from her inexperience, but there was something satisfying about holding something that her own hands had literally shaped from raw metal. For the first time in her life, she understood the difference between using a tool and being a craftsperson. "All right," Elena announced, "time for the real test. We need to assemble these components into a functional quantum resonance chamber and then integrate it with the atmosphere processor's control systems. And we need to do it in a way that can be replicated on Kepler 442b using whatever tools and materials they have available." The next phase of their education was even more challenging than the forging. It required not just individual skill, but coordination, communication, and the kind of intuitive teamwork that came from shared understanding of materials and processes. Maya found herself calling out to Marcus to adjust pressure while she held the component in place, relying on Lieutenant Martinez to judge the precise moment when a weld was ready, trusting Dr. Park's calculations while simultaneously knowing that the numbers were just guidelines for what her hands needed to feel. "This is impossible," Marcus said at one point, sweat dripping onto his workstation. They were attempting to calibrate the quantum resonance frequencies by hand, using instruments that required constant manual adjustment. The tolerances are too tight. We need computer control to maintain the necessary precision. Elena appeared beside him, her own hands moving over the controls with practiced ease. The tolerances aren't too tight. Your expectations are too rigid. She made a series of small adjustments, and suddenly the resonance frequencies locked into perfect harmony. See? You were trying to hit an exact number. But the system doesn't want an exact number. It wants a dynamic balance. How did you know what adjustments to make? Dr. Park asked, studying the readings with fascination. I listened, Elena said simply. The harmonic frequency has a sound. When it's right, you can hear it. When it's wrong, it sounds. She paused, searching for words. Anxious, like the system is working too hard to maintain stability. Maya closed her eyes and tried to hear what Elena was describing. At first, there was just noise, the hum of machinery, the clash of metal on metal, the voices of other workers. But gradually, she began to distinguish individual sounds within the mechanical symphony. The atmosphere processor's model did have a voice, and when Elena adjusted the settings, that voice changed from stress to confident. I can hear it, she said, wonder creeping into her voice. It actually sounds different when the settings are right. Of course it does, Elena smiled. Machines are honest. They tell you exactly what's happening if you know how to listen. The problem is that your generation learned to trust instruments more than intuition, data more than experience. As they worked, Maya began to understand that what Elena was teaching them went far beyond technical skills. She was teaching them a different way of relating to technology, not as consumers of automated services, but as partners in an ongoing conversation between human intelligence and mechanical capability. The assembled quantum resonance chamber was ugly by modern standards. Its surfaces were scarred from hand forging. Its connections showed the irregularity of manual assembly, and its control interfaces required constant attention from a human operator. But when they activated it, the chamber achieved resonance frequencies that their portable instruments couldn't even measure accurately. It's working better than the original specifications, Dr. Park said, staring at his readings in disbelief. The efficiency ratings are actually higher than what the Yamamoto-chin design was supposed to achieve. Because it's not fighting itself, Elena explained. The original design tried to achieve perfection through rigidity. This version achieves excellence through adaptation. It responds to changing conditions instead of trying to force unchanging parameters. Maya looked at the chronometer. They had been working for 8 hours, and they had less than 3 hours left before the atmosphere processor on Kepler 442b failed completely. Even if they could transmit complete instructions immediately, it would take time to gather materials and assemble a replacement chamber. Elena, she said, we need to know if this is actually going to work. Can people who have never done this kind of work before build a replacement chamber in time to save those lives? Elena considered the question seriously. Honestly, probably not. The learning curve is too steep, and you don't have enough time. But she moved to a communication console and activated a wideband transmission. This is Elena Vasquez at Frontier Station, calling all Makers Guild members within 5 light years of the Kepler 442 system. We have a code, read emergency situation. The response was immediate. Voices began responding from locations Maya had never heard of, tiny mining stations, agricultural worlds, research outposts that didn't appear on any official registry. One by one, people identified themselves as having relevant skills and available transportation. Elena, this is Chin Morrison on Salvage Station Beta 7. I've got atmosphere processing experience and can be at Kepler 442b in 90 minutes. Vasquez, this is Maria Santos aboard the Independent Freighter Determination. I'm already in the Kepler system doing a supply run. What do you need? Elena, this is the entire technical crew of Mining Station Prometheus. We're 8 hours out, but we've got fabrication equipment and people who know how to use it. Maya listened in amazement as more than 30 people volunteered to drop everything and travel to Kepler 442b. These weren't official emergency responders or government employees. They were individuals who had maintained the old skills, scattered across the frontier systems, who were willing to risk their lives to save people they had never met. How many of them are there? Lieutenant Martinez asked. More than Central Authority realizes, Elena replied. People who got tired of depending on systems they couldn't fix. People who wanted to understand how things actually work. People who believe that humans should know how to build the things they depend on. She looked around at Maya's team. People who have been waiting for someone from the core worlds to finally ask for help. Dr. Park was staring at the communication console. They're really going to do this? Travel across space to fix a machine for people they've never met. That's what humans do, Elena said simply. At least, it's what humans used to do before they got so comfortable that they forgot what it means to depend on each other. Maya understood now that the crisis on Kepler 442b was about more than just a failing atmospheric processor. It was about rediscovering the connections between people, the knowledge that had been scattered to the frontier worlds, and the skills that had been dismissed as obsolete. The volunteers who were converging on the planet weren't just bringing technical expertise. They were bringing a different vision of what human civilization could be. Elena, Maya said, when this is over, when we've saved those 2 billion people, what happens next? Do we go back to depending on systems we don't understand? Or do we actually change something? Elena looked at her for a long moment, then at the quantum resonance chamber they had built together, scarred and imperfect, and more functional than anything that had rolled off an automated production line. That's up to you, she said. All of you. The knowledge exists. The people exist. The question is whether the core worlds are ready to admit they need what we've preserved out here on the frontier. She gestured toward the communication console, where status reports were still coming in from volunteers racing toward Kepler 442b. Because I can tell you right now, we're ready to teach. We've been ready for a long time.